Hello. Now we're going to solve problem 3.2.7.4, cost of living index. Between April and June 2017, a cost of living index was created for all 50 states plus the District of Columbia. The mean state index is 104.87 with a population standard deviation of 18.01. If we know the cost of living index is normally distributed, then what is the probability that a state has a cost of living index over 145.6, the value for the state of California? So by knowing the data is normally distributed, we can find out some interesting results with only being given 3 numbers. When I do these types of problems, I do parts of them in Excel and parts of it by hand. I like to draw the normal curve as a diagram, which is difficult to do in Excel. So I'll switch screens and go to the pad. I would also likely just do this on paper, but it's hard to show via video. Let's start by drawing a generic normal curve. There are several things to remember about the normal curve. The area under the normal curve is 1, it is symmetric, and the center of the normal curve is the mean. So here's our mean, cost of living index mu, with a value of 104.87. The curve has a standard deviation of 18.01, which tells us how wide the curve is. However, we do not hand draw these curves to scale, so it would change our hand drawing. We want to find the probability of drawing a state that is higher than 145.6, the value of California. The 145.6 value needs to be to the right of the mean value, 104.87, but we are guessing how far to the right it is. The graph, even if not to scale, will be helpful. We'll first solve this problem by hand, and then we'll look at tools in Excel that will let us solve it faster, but not always as intuitive. In this problem, we want to find the area of the right tail above 145.6. This area is the probability that a state has a higher cost of living than California. To be able to use the normal standard distribution table, I need to convert my data into a z-score. The formula to calculate z is x minus mu over sigma. The value of x is 145.6. The value for mu is 104.87. The value for sigma is 18.01. You can calculate this with a calculator on Excel or calculator or in Excel. Let's quickly calculate in Excel. I'm going to stop share and then go back to our spreadsheet. In Excel, I'll put x equals 145.6. Mu equals 104.87. Sigma equals 18.01. Because it's inconvenient to get the Greek letters, we will just spell them. Now to calculate the z-score, put equal sign, open parenthesis, x minus mu, close parenthesis, divided by sigma. Then press enter. Rounding the result to 2 digits gives us the value z equals 2.26. Let's switch screens and go back to the pad. Now the z value equals 2.26. We can plot the z values that we know. The z-score associated with 145.6 is 2.26. The z-score associated with the mean is z equals 0. The mean always has a z-score of 0 because the formula is x minus mu in the numerator, and that equals 0. Okay, now we want to find the area to the right of 2.26. First, we'll look at the standard normal distribution table, and then we'll look at some formulas in Excel to solve it. Let's switch screens to see the standard normal distribution table. The standard normal distribution table will give us the area to the left of any z-score. The graph at the right reminds us that we are given the area to the left. We want to find 2.26. So scroll down to find 2.2, which is row 58. The first column is 2.20. The second column is 2.21. And the seventh column is 2.26. We get a value of 0.9881. So the area to the left of z equals 2.26 is 0.9881. I'm going to stop sharing and go back to the pad. So 0.9881 is the area to the left of z equals 2.26. Because the area under the normal distribution is 1, the area to the right equals 1 minus 0.9881, which equals 0.0119. So there is a 1.2% probability that we will randomly draw a state that has a higher cost of living than California. I prefer drawing these diagrams and solving this type of problem. However, we have tools in Excel to make it faster. Now let's go back to our Excel sheet. We will write it more formally because we can't show it on the graph. Then we'll use Excel formulas to solve it. So more formally, we're trying to find the probability that x is greater than 145.6. However, I want to use the standard normal distribution table. I need to convert that into the probability that z is greater than 2.26. The table and the Excel formulas do not give us the area to the right, greater than, but the area to the left, less than a given z-score. But the total area under the curve is 1. So the area to the right is equal to 1 minus the area to the left, or for this problem, 1 minus the probability that z is less than 2.26. We can find the probability that z is less than 2.26 by looking at the standard normal distribution table, or we can start using Excel formulas. There are two formulas. The first is norm.s.dist, which has you enter the z-score. So put equals norm.s.dist, open parenthesis, 2.26, comma, true, close parenthesis. The 2.26 is our z-score, and the true means that we want the area to the left of that score. False means we want the y value of the curve at that z-score. I don't think you will ever use it. This gives us an answer that rounds to the fourth digit for the value we have in the table, 0.9881. Alternatively, you can use equal norm.s.dist, open parenthesis, click on B9, put a comma, then type true, close parenthesis, and you'll get a more exact number because the z-score is not being rounded. Then you get 0.9881. Finally, if you don't want to calculate the z-score, you can use norm.dist. Norm.dist asks for the x value, the mean mu, the standard deviation sigma, and then true or false. Norm.dist just asks for the information to internally calculate the z-score and then gives you the same answer as norm.s.dist. So enter equals norm.dist, open parenthesis, then click on B5, comma, click on B6, comma, click on B7, comma, then type true, close parenthesis. The value Excel calculates is the same at 0.9881. To get the final answer, calculate equals 1 minus, and then click on the cell with the area to the left to get 0.0119. So the answer to the problem, we randomly chose a state, to the probability we randomly chose a state with a cost of living index over 154.6 is 1.2%. That is the answer to 3.2.7.4.